Hello, we're looking at how to take the derivative of this function. It was on the test review, and a few of you had asked a question about this, so here's a video to help you see how to do that. So we are looking for the derivative of that. So first thing we can do, and this is one option, is we can move it to the numerator. In other words, we're going to move that up, and in doing so we make the exponent negative. From here we can use the product rule. So the negative 5 comes down and multiplies with the negative 3, giving me 15x, and then negative 5 minus 1 is going to turn that to a negative 6. At that point we'll move it back down, so 15 over x to the 6th power, and that would be our derivative. So that's probably your easiest way to look at that. And what we can do now is kind of a different way, just to show you that there's usually more than one option here. So the other way to do this would be with the quotient rule, and that's what most of you tried when you came in. It's not quite as fast, but it should work. So the derivative of the top comes first. The derivative of negative 3 is 0 times the original bottom minus the original top times the derivative of the bottom. So those are the numbers divided by the bottom squared. Then we simplify. This part's going to cancel out because it's a 0. And here we have negative 15, so that's going to turn into positive. And then on the bottom we have 5 times 2, so x to the 10th. At this point we have a property that says we can subtract the exponents, and that gives us negative 6. So we're back at 15x to the negative 6, which would turn back into 15x over 6. In other words, at this point, 4 of our x's there will cancel with some of the 10 here, leaving us with 6 on the bottom. That would be another way to look at that. Either way, we end up with this as our answer, though.